In this problem, we want to solve x over x plus 5 plus 3x over x squared plus 7x plus 10 equals 2 over x plus 2. This is a rational equation. Of course, it's an equation. It's got an equals solving for x. Rational because we got fractions, specifically with variables in the denominator. Now, our steps for solving a rational equation. Rational equations solving. Our first step is to get rid of parentheses. Usually this is with the distributive property, and I'll put that there. So that's what most of the problems involve, if they have parentheses at all. But it doesn't have to. You could multiply two binomials together, FOIL it. Step 2, get rid of fractions. We'll multiply by the LCM of all the denominators. Now at this point we're getting rid of the fractions, and step 3 is kind of vague. It says solve for x. What you'll find at this point is it'll either be a linear equation, and then use your 4 steps to solve, or it'll be a quadratic equation, and you'll use a zero factor property. It's also called a zero product principle, zero product property, lots of different names you'll see that called. It's possible you might have to use a quadratic formula, but I'm not sure if I've seen very many of those in an algebra book where it combines a rational equation with a quadratic formula. Actually, I'm not sure if I've seen any. And step 4 is to check your answers. Now, we'll be very specific on checking our answers there. We just want to make sure that our answer doesn't cause a denominator to equal 0. So let's take a look at this problem. Okay, so we got x over x plus 5 plus 3x over x squared plus 7x plus 10 is equal to 2 over x plus 2. Step 1, get rid of parentheses. Don't have any. Step 2, get rid of fractions. Multiply by the LCM of all the denominators. In order to figure out the LCM, you have to factor all of your denominators as these become more complex. Now, x plus 5 and x plus 2 we can't factor, but x squared plus 7x plus 10, that would be the PSD method. And I'll do it over here on the side. And you may have learned that with a different technique. And if you did, that's fine. It's PSD because we have x squared x, no number in front of our x squared. With the PSD, we take the number at the end, which is 10, ignoring signs, and we come up with our 3 columns. Our P column, our S column, and our D column. Remember the P column, we write down all products give us 10. We got 1 times 10 and 2 times 5. In the S column, we want to add these together. S for sum. 1 plus 10 is 11. 2 plus 5 is 7. In the difference column, D for difference, we subtract smaller from larger. 10 minus 1 is 9. 5 minus 2 is 3. Now the number we're looking for is a number in our middle term, which is 7, which is right here, which means we're going to use 2 and 5. Now the last thing we have to determine is what our sign is going to be. The larger number in the P column that you're using, which is the 5, will always be the same sign as the middle term, which in this problem is a positive. Now the number I circled in the S column, S for same sign, so if this one's positive, then this one has to be positive. So this becomes x over x plus 5 plus 3x over x plus 2 times x plus 5 equals 2 over x plus 2. So we had to factor our denominator to help us figure out what the LCM is. So let's start with our first factor, the x plus 5. I'm looking for the greatest number of x plus 5s in a single denominator. There's one here, there's one here, there's none here. So we're going to have 1. We don't count how many there are. We're looking for the greatest number in a single denominator. Then I go to my next factor, the x plus 2. There's none here, there's one here, there's one here. So our greatest number of x plus 2s in a single denominator is 1. And that's our LCM. So we'll multiply times our first fraction. We'll multiply it times the next fraction. And then we'll multiply it times fraction on the right side. Well, this x plus 5 here cancels this x plus 5. This x plus 2 cancels that x plus 2. This x plus 5 cancels that x plus 5. And over here, this x plus 2 cancels with this x plus 2. Now let's write down what we have left. So we got x times x plus 2 plus 3x equals 2 times x plus 5. And x times x is x squared. X times 2 is 2x plus 3x equals 2 times x is 2x, 2 times 5 is 10. Distributive property. Same over here. You always combine together like terms no matter where you are in math. 2x plus 3x is 5x. And now we're ready for step 3. Step 3 said solve for x. Very vague. But then notice we have a quadratic equation. The reason why we have a quadratic equation is because we have an x squared. Now with a quadratic equation, we want to get 0 on one side. So I'm going to take this 2x and move it over, and I'll take this 10 and move it over. Remember, you move anything across or equals, your sign changes. So we got x squared plus 5x minus 2x minus 10 equal to 0. X squared plus 3x minus 10 equal to 0. Now where we're headed with this is we want to use the zero factor property to solve it. Zero factor property says you get 0 one side, and then you factor the other side. Well, this would be the PSD method, again, because we have an x squared x, no x. So at the PSD method, we take the number at the end, the 10, ignoring signs, and we create our 3 columns. Same numbers as above. So we got 1 times 10, 2 times 5. Add them. 1 plus 10 is 11. 2 plus 5 is 7. Subtract them. 10 minus 1 is 9. 5 minus 2 is 3. This time the number we're looking for is a 3, which is right here. So we're going to use 2 and 5. So we got x2, x5. Now our larger number in the p column that we're using, which is the 5, will always be the same sign as the middle term, which in this problem is or right at this step, is a positive. Remember, our circle's in the difference column, D for different signs. So if this one's positive, this one has to be negative. Now the zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x minus 2 equal to 0 and x plus 5 equal to 0. And solve those, and we get x equals 2 and x is equal to negative 5. Maybe. Because remember, step 4 was to check your answers. Now if I put 2 back up my original problem, 2 plus 7, or 2 plus 5 is 7, that's not 0. 2 squared plus 7 times 2, well 2 squared is 4, 7 times 2 is 14, plus 10, that's not 0. Here, 2 plus 2 is 4, that's not 0. We really don't care what the value is, we just want to make sure it doesn't equal 0. So x equals 2 checks. Now negative 5. If I put negative 5 up here, negative 5 plus 5 is 0. That causes the denominator to equal 0. So we do not use that answer, we cross it off. So our only answer in this problem is x equals 2.